This is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the processes that result in each of the different major families of the rock cycle: igneous, metamorphic, and sedimentary. Let's begin our discussion with this figure from the book, which shows examples of igneous, sedimentary, and metamorphic rocks. The textbook is organized according to this order. We're going to begin with igneous rocks, then move on to sedimentary rocks, and finally come to metamorphic rocks. Here's a sample of an igneous rock. It's a vesicular basalt. Basically, the way that this rock type forms is from lava. So what all igneous rocks have in common is that they form from molten rock, either lava if it's above ground or magma if it's below ground. Here's an example of a sandstone. This is a quartz sandstone, such as the one shown in the center image. Sandstone, you may be shocked to learn, comes from sand. And in the case of this middle image in Zion National Park, the structures within the sandstone suggest that it formed in a dune environment. So sand is also present in large concentrations in certain rivers and on beaches, but this seems to be a dune sandstone. Lastly, here's an example of a schist. Schist is a kind of metamorphic rock, such as is found at the bottom of the Grand Canyon, as you see in the bottom center image. And the way schist forms is at the roots of large mountain belts. So when mountains are being thrust upwards into the sky, deep underneath those mountains, the rocks are getting ground around and squished and squeezed and warmed up, and it causes transformations in the rock. So schist is an example of a metamorphic rock. So again, top to bottom, igneous, sedimentary, and metamorphic rocks. This diagram in the textbook describes the rock cycle. Basically, the rock cycle is the collection of processes that result in the different major rock families, the three that we just described. Plus, we've got two sort of hubs on this rock cycle diagram that show sediment and show magma. So let's begin with the molten rock, the magma in the upper left there. If it's underground, molten rock is referred to as magma. If it is above ground, it's referred to as lava. What ends up happening is as it cools down and crystallizes, it produces igneous rock. The igneous rock can come in a couple of different varieties. It can be extrusive if it forms on the surface of the earth, or intrusive if it forms below the surface of the earth. But if that igneous rock is then exposed to weathering, so the extrusive igneous rock is already at the surface, but if the intrusive igneous rock is brought to the surface, then it's exposed to the forces of weathering. And basically this means that the rock starts to break down. It turns into sediment, and that sediment is stripped away from its area of origin. It's transported some distance, perhaps down a river system, and then it's dumped somewhere or deposited. And so those deposits of sediment often accumulate in layers, such as is seen in the lower right. Now those layers of sediment can end up getting stuck together by the processes of lithification. Basically, the sedimentary grains get packed together, or they get a sort of mineral glue that holds them together, a cement. And so compaction and cementation result in turning the sediment into sedimentary rock. So we've seen igneous rock form and sedimentary rock form. What about the last group, metamorphic rocks? Well, that's where we're headed next. Metamorphism is chemical and physical reorganization of the rock that accompanies higher temperatures and pressures. So when heat and intense pressure are applied to a pre-existing rock, in this case a sedimentary rock, it transforms to become a metamorphic rock. That metamorphic rock itself could then get heated up even further and begin to melt. If it melts, then it's going to produce magma again. So we return to the beginning of our rock cycle diagram here by undergoing the process of melting. Now all the arrows in the middle of this diagram represent alternate pathways, where you could take an igneous rock, for instance, and then you could transform it back into another igneous rock by following that pathway. Or you could take that igneous rock and you could metamorphose it. Or you could take a metamorphic rock and turn it into sediment, and then that sediment could become a sedimentary rock, and then that sedimentary rock could become sediment, and metamorphism could occur to a pre-existing metamorphic rock, and so on and so forth. So the rock cycle actually is fairly complicated if you consider all the different possible pathways a rock could go down. The key thing to get from this is that these purple arrows represent processes. All right, so processes that need to take place in order to transform a rock from one rock type to another. So in the review material at the end of the chapter, you'll find this diagram, which basically shows sediment transformed into sedimentary rock, transformed into magma, transformed into igneous rock. And an exercise that you could go through is to, pick any, set of characters like these and then go back to the rock cycle diagram and think about what pathways would have to be followed in order to make that story work. So with our story, we started off with sediment, and then that gets transformed into sedimentary rock, and then we saw melting take place to produce magma, and then cooling of that magma to produce igneous rock. So that was the story we just saw played out on the previous screen. But you could tell a very different story following a different set of arrows here. So maybe for review, ask yourself, what sort of story would I have if I had an igneous rock that then melts and then forms another igneous rock, which then gets metamorphosed? Which sets of arrows would you have to follow to make that work? All right, thank you for your attention. This has been another Smart Figure.